All right, let's take a little trip back to algebra class. We're going to talk about something almost all of us were taught, a super common method for multiplying two sets of parentheses together. But here's the question. Is this famous technique really the best way to learn, or is it kind of setting a trap for us later on? Let's get into it. So take a look at this. X plus 3 times x plus 5. This has got to look familiar, right? When you saw this on the chalkboard, what's the first thing that popped into your head? For a whole lot of us, it was probably the exact same four-letter word. And no, not that kind of four-letter word. It was a trick, a little memory aid that was supposed to make the whole process completely foolproof. And that word, of course, is FOIL. It's been a cornerstone of high school algebra for like 100 years. Just a simple little recipe for getting the job done. So FOIL is basically our checklist. You kick things off with F for first, multiplying the first term in each parenthesis. So x times x. Then you've got O for the outer terms, the ones on the very ends. That's x times 5. Next up is I for the inner terms, the two guys in the middle, 3 times x. And you wrap it up with L for the last terms, 3 times 5. See? It gives you a really clear step-by-step path. And this right here is exactly why it's so dang popular. You do those 4 little multiplications, you combine the two terms in the middle, and boom, you get the right answer, x squared plus 8x plus 15. It's easy, you remember it, and hey, it works. So what's the problem, right? Well, this is where the debate in math education really starts to get interesting. See, just because something is a good trick for getting an answer doesn't automatically mean it's the best tool for actually understanding what you're doing. And some educators, well, they do not hold back. This quote from a math help forum really just cuts right to the chase. The argument is that FOIL isn't real math, it's just a gimmick. And that really gets to the heart of the critique. The big issue is that FOIL is just a memory aid. It tells you how to do it, but it never explains why it works. And its biggest flaw? It's a total one-trick pony. It only works when you're multiplying two simple binomials, and it's useless for anything more complicated. I mean, what happens when you run into a problem like this one? You've got 3 terms in the first parentheses and 2 in the second. Your trusty FOIL method just completely falls apart. There's no first, outer, inner, last that's going to save you here. And this is the exact moment where students who only learn the trick get totally stuck. So let's look at another way to do this, a way that actually builds a deeper understanding. A lot of teachers now prefer something called the area model, or sometimes the box method. It's way more visual and, you'll see, a lot more flexible. Here's how it works. You just draw a grid. The terms from one polynomial go across the top, and the terms from the other go down the side. Then you just fill in each box by multiplying, kind of like a times table from elementary school. After that, you just add up everything inside the box and combine any like terms. It's super organized, and it's really hard to accidentally miss a piece. And this is where the area model really flexes its muscles. It handles that impossible problem from before with no sweat. All you do is make the box bigger. In this case, a 3x2 grid. You fill it in, you combine the terms, and you get the full correct answer. There are no new rules to memorize. The basic idea just scales right up. Okay, but hang on a minute. Let's go back to our original simple problem, the x plus 3, x plus 5. If you look at the 4 terms we got from doing FOIL, and then you look at the 4 terms we got from inside the area model box, they're exactly the same. So what is really going on here? If they're both spitting out the same 4 pieces, are they really all that different? This brings us to the real magic trick, the core mathematical idea that's actually powering both of these methods. Turns out, they're not 2 different rules competing with each other. They're both just different ways of looking at one single fundamental property of numbers. And that principle is the distributive property. All it says is that if you're multiplying something by a group of things being added together, it's the same as doing each multiplication one at a time. So here, the A gets distributed or shared with both the B and the C. Okay, now check this out. To multiply 2 binomials, all you're really doing is using the distributive property twice. First, you take the entire second parentheses, the C plus D, and you distribute it to the A and then to the B. Then you just do it again for each of those new parts. And what's the result? You get the exact same 4 products we got from FOIL and from the area model. And that is the absolute key takeaway. FOIL is just a mnemonic. a memory trick that helps you remember the 4 steps of double distribution. The area model is a visual way to organize those same 4 steps, but the math itself, the math has always been the distributive property.
So why does any of this even matter? I mean, who cares how you get the answer as long as it's the right one? Well, this really gets to the heart of what it actually means to learn mathematics in the first place.
The whole debate really boils down to this. On one hand, you have FOIL. It's a great shortcut, it's easy to remember, it helps beginners get some quick wins. But it's basically a dead end. It hides the why behind the math, and it can't adapt. On the other hand, focusing on distribution, maybe using the area model to visualize it, might feel a little slower at first, but it builds a flexible, deep understanding that can solve any of these kinds of problems you'll ever see. And that's really the core of it all. Learning the why, in this case, the distributive property, is what actually empowers you. It turns math from this long list of boring rules to memorize into a creative tool you can use for solving problems. It gives you the power to figure out challenges you've never even seen before. So I'll leave you with this to chew on. When it comes to learning, not just in math, but in anything, is a simple shortcut that gets you a quick answer really worth it if it keeps you from seeing the beautiful, powerful, and connected bigger picture. Something to think about. Thanks so much for joining me.